Again, welcome to College Algebra. In these lectures, we're going to discuss about absolute values. This is our Unit 7, Lecture Part 8. So our main objective is to define and also use absolute values in solving equations. That's equations with absolute variable, as we can see, absolute variable x. Also inequalities equation with absolute variable x, either less than k or greater than k. Also, we're going to learn how to solve the compound inequalities with absolute values. Again, our previous lectures, we solved different types of inequalities equation, and one of them was solving compound inequality equation, but without absolute value or absolute variable. Here we are going to solve an equality equations with a variable that is an absolute value. So let's start with defining and the use of absolute value. So here we say that the absolute value of the real number x is normally denoted by a vertical two lines, and the variable is between the two vertical lines. So here we have what we call the absolute value of x. Now what this means is that if s is greater than or equal to 0, which means if s value is positive, the answer will be positive. Also, if s value is less than 0, the absolute value always is positive. So here, for example, we say negative x. So what we mean by x and negative x means, for example, if we have absolute value of 7, the answer is 7. If we have absolute value of negative 7, the answer is say positive 7. So with absolute values, always our result will be a positive solution. So because of this, when we are solving an equation with a variable as an absolute variable, we have to find the value when it's positive and also the value when it's negative. So in this case, I will find negative x and also positive x. So it's 2. So that's what we mean by the definition here. The absolute value of x variable, the result will be x and also negative x. Because negative x absolute, the answer is x. Positive x absolute value, the answer also is x. And again, we're going to see an example with values. So for example, here we have the absolute value of 7. What is the answer? It's positive. 7 is positive, so the answer is 7. Now, what of the absolute value of negative 3? This is where we have to say that if the value is either positive or negative, our answer always will be positive. So the absolute value of negative 3, the answer will be positive 3. So here we say that the absolute negative 3 will give us negative times negative 3, which will be positive. Now the next example, we have negative absolute value, negative 7. So first, we can see that the negative outside the absolute value doesn't have anything to do with the negative 7. So first, I have to find the solution of negative 7. Then I'll multiply it by negative 1 or negative. Now, since we said that absolute value, whether the number is positive or negative, always our answer will be positive. So the absolute value of negative 7 will be 7. Then times negative or negative 1, the answer will be negative 7. So here the answer will be negative 7. Here we have only negative 3. So the absolute value of negative 3 will be positive 3. So that's what we have here. We have the negative. We don't touch the negative outside the absolute. But we know the absolute value of negative 7 is positive 7. And the negative, we included it. So the answer will be negative 7. Now, if I'm looking for absolute value of our last example, is the absolute value of x minus 2. Now, this is what we are going to do a lot because we have x minus 2 in the absolute. So the answer can be either positive or negative. So here we say that x minus 2 can be greater than or equal to 0, which means it's positive. In that case, the absolute value x minus 2 will be s minus 2. Now, if s minus 2 is negative, which is less than 0, this means the absolute value of s minus 2 will be negative, then s minus 2. So it will be minus s plus 2. Again, minus s plus 2 means we multiply the negative by x and negative 2. So negative times positive x will give me negative x. Negative times negative will give me positive, so we get positive 2. Now, this is what we are going to do a lot in these lectures. Absolute value of x minus 2. This is telling us that if, because we don't know the value of the variable can be 1 and the answer will be negative value, or it can be 3, the answer will be positive value. So we have to assume the two conditions. The first condition is if the s value make it possible. Again, we don't know the value of x. The previous example, for example, negative 7, yeah, we know what is negative 7. The absolute value of negative 7 is 7. But what is the absolute value of x? It will be x. What is the absolute value of negative x? It will be x. So that's the condition we are putting here. So if s minus 2 is positive, the answer will be s minus 2. If s minus 2 value is negative, then it will be negative, then absolute value of s minus 2 is still s minus 2 with a negative outside. So again, multiply the negative with the expression, we get negative s plus 2. So now let's start to solve equations with absolute variables. So we're going to start with the solving equation of the form absolute variable x equal to k. K can be any value. So here we say that if k is greater than or equal to 0, then we can say the absolute value s equal to k. It's equivalent to saying s equal to k or s equal to negative k. Again, we have the definition saying that if I have a variable x absolute, the answer is two options. It can be either positive x or negative x. We give us the same k. So that's what we have. So now let's solve an example. Here they say we should solve the following equation. We have absolute value 3s minus 3s minus 5, then plus 3 equal to 10. So the first thing I'm going to do is to remove the 3. So I'm going to use negative 3 to cancel the positive 3. And anything we do to the left side of the equation, we have to do the same thing to the right side of the equation. Same method of solving simple equations. So that's what we did here. We have negative 3 and negative 3 on the right side of the equal sign. So positive 3 will cancel negative 3, and 10 minus 3 will give me 7. So we get 3s minus 5 absolute equal to 7. Now our goal is to get rid of the absolute, find a solution. As the definition said, we have a variable x, which means there's a possibility that 3s minus 5 will be greater than 0 or equal to 0, which is positive value, or 3s minus 5 will be less than 0, which means it's negative. So with that, always we have to apply that condition. That was the definition we learned. So this means absolute value 3s minus 5 equal to 7 is the same as writing what? 3s minus 5 equal to 7, or 3s minus 5 equal to negative 7. Because the answer here, whether the solution is positive or negative, we get 7, two options. So here we have 3s minus 5 equal to 7. We solve a simple equation. We use plus 5 to cancel minus 5. We have to have plus 5 to the 7. So we get 3s equal to 12. Now we are looking for x. X is multiplied by 3. So we are going to divide by 3. And that gives us s, 3s divided by 3. And also 12 divided by 3, that will give me 4. So our first solution will be s equal to 4. The next one, we say 3s minus 5 equal to negative 7. So the same thing we do, use plus 5 to cancel negative 5. But this time we get minus 7 plus 5, which will give me minus 2. Then I'm going to divide the left side and the right side of the equation equal sign by 3 so that I can get x. So my solution will be negative 2/3. Now this means, remember, we are doing absolute equation. We said if I have negative 6, absolute value, the answer is positive 6. If I have absolute of 6, the answer is still positive 6. So that's why we do these two conditions here. Now by looking here, the lowest value is negative 2/3 and the highest value is 4. So we say the solution set consists of a point shown in the figure, negative 2/3 and 4. Remember, this is not inequality, this is equality. It's just that we are solving an equation, equality equation or simple equation with absolute expression. Now let's solve equation with two absolute values. So here we said that if we have a and b that represent algebraic expression, the equation absolute value a equal to absolute value is same as writing a equal to b or a equal to negative b, the same rule we had previously. So now if I have an expression to solve absolute value 2s equal to absolute value s minus 3, here we say this equation absolute 2x equal to absolute s minus 3 will be true only when 2x and s minus 3 are equal, and also when they are negatives. So this will give us two equations which can be solved separately. First, when they are equal, and secondly, when they are negatives. So the first condition, we have 2s equal to s minus 3, they are equal. Or negative 2x negative s minus 3, which is 2s equal to negative s minus 3. So here, again, we have s will give us negative 3. Why? Because we have x here, and we have minus 3, and we also have 2x. So I will take this x to the left side, so I'll get 2s minus x. 2s minus s will give me x, and it's left with negative 3. Here, the first thing I'll do is remove the parentheses, so I'll get negative s plus 3. That's what we have here. Now we take our negative x. When it crosses the equal sign, the sign changes, so we get 2s plus x. So 2s plus s will give us 3s, which is equal to 3. We divide both sides by 3, we get 1. Now what I'm explaining here is that we can also say that, okay, I have this. So I have x, 2x, which is greater than negative 1x. So I'm going to cancel negative 1x using positive x. So I have plus x to the right side plus x to the left side of the equal sign. So that means 2s plus x will give me 3s, and minus s plus s will cancel each other, and it will left with only 3. We divide both sides of the equation by 3, and we get 1. Now let's solve inequalities of the form. We have absolute value variable x is less than k, and also our absolute value variable s is less than or equal to k. So here we say that if k is greater than 0, then this is the rule. Here we say that inequality of the form absolute value s is less than k and absolute value s is less than or equal to k. Only if k greater than 0, which means again k is a positive value and it's not 0, greater than 0. Then we can say that absolute x less than k is equivalent to x should be greater than negative k, and it should be less than k. That will be the range. Now, if it's less than or equal to k, then same idea. It should be greater than or equal to negative k and less than or equal to k. This condition will hold only if k is greater than 0, and we can insert in any value. Remember that we said in inequality equation, if I multiply or dividing with a negative sign value, the sign will change. So if it's greater, it will change to lesser. If it's lesser, it will change. But if it's positive value, that's why this condition is positive. The sign doesn't change. So that's why this rules hold. It's true. So now let's solve an equation here. Here we have s minus 2, absolute inequality again, less than 7. So absolute value s minus 2 less than 7. Our goal is to find the value of x. So the inequality s minus 2 absolute less than 7 is equivalent to writing s minus 2 is greater than 7 or less, it's less than 7 or greater than negative 7. Remember the rule. 7 is a positive value. So if k is greater than 0, if it's a positive value, and s is less than k, then we can say that, okay, s will be in the range from negative k to k. So it will be greater than negative k and less than k. Now, if it's less than or equal, then it will be greater than or equal to negative k and less than or equal to k. And since here we have 7, that's the rule we apply. So from here, we can solve our problem. Let's cancel the negative 2, and we need positive 2 to cancel it. So I have to add positive 2 to my left side of the inequality, positive 2, all the 3 sections. So negative 7, positive 2 will give me negative 5. Then negative 2 plus 2 will cancel each other, so it will left with only x. Then here I have 7 and also positive 2, so that will give me 9. So this means my answer is x should be greater than negative 5 and also less than 9. So we can grab the range. This is again inequality. So we have the range from negative 5 to 9. Remember, when we are solving the equality equation or simple equation, we get only dots. And the answer is not a range, it's an equal sign. So we have a dot. So 4, negative 2/3. So negative 2/3 and 4, not the range. But with inequality, again, we have a range. So again, this is the example. 7 is positive value, so we can rewrite it as s minus 2 less than 7, and s minus 2 is greater than negative 7. That's what the rule said, and that's what we did to solve the value of x. Now let's solve inequality of the form. This time we are using, previously we used less than equal, this time greater than k and greater than or equal to k. And the rule is of the same concept. The only thing we should pay attention to the sign. So here we say that if s is greater than k, and also s is greater than or equal to k. Now, if k is a positive value, then we have absolute s greater than k is the same as saying that s is less than negative k, or s is greater than k. And with the greater or equal to the same concept, s will be less than or equal to negative k, or s is greater than or equal to k. Now we have to pay attention to the sign. Again, the sign has to be positive. So let's solve this problem. We have 2s plus 3 divided by 2 plus 7 greater than or equal to 12. So here we look at our condition. Even if we take the plus 7 to the right side, we still have a positive value, which will be 5. And that's the first thing we do. Then we look at the condition here. Okay, k is positive value. So we can apply the condition. 2s plus 3 divided by 2 is less than or equal to negative 5. Or 2s plus 3 divided by 2 is greater than or equal to 5. Again, we are applying the rule here. If k is positive, that's greater than 0, and we have s greater than k, and also absolute s greater than or equal to k, then we can apply these two, or we can apply these two rules. So when s is greater than k, it's equivalent to s is less than or equal to k, or s is greater than k. Or if s, absolute value s is greater than or equal to k, it's equivalent to saying x is less than or equal to negative k, or s is greater than or equal to k. And that was the example here. So here we have 2s plus 3 divided by 2, absolute plus 7 greater than or equal to 12. So first I'll take the 7 to the right side. So it will be 12 minus 7, which gives us 5. Since 5 is a positive value, then the rule will apply. We get 2s plus 3 divided by 2 less than negative 5, and 2s plus 3 divided by 2 greater than or so here less than or equal, there's equal sign, or greater than equal to 5, and that's what we have here. 2s plus 3 divided by 2 less than or equal to negative 5 according to our rule, and 2s plus 3 divided by 2 is greater than or equal to 5. So we solve the two equations. Here we have 2 multiplying, dividing. So we are going to multiply by 2 both sides to cancel the 2. So negative 5 times 2 will give me negative 10, and 2 divided by 2, they cancel each other. Then from here we have plus 3 here. So I'll use minus 3 to cancel plus 3, and I also have minus 3 here. So I'll get 2x less than or equal to minus 13, because plus 10 minus 3 will give me minus 13. Now 2 is multiplied by x, so I'm going to divide both sides by 2. So I'll get x is less than or equal to negative 13 divided by 2. So that will be our first solution. Second solution, we have 2s plus 3 divided by 2 greater than or equal to 5. So 2 is dividing, we multiply everything by 2 here. So 2 divided by 2 will cancel the 2 down here, so we have only 2s plus 3. 2 times 5 will give us positive 10. And we have plus 3 here, so we use minus 3 for both sides. We get 2s greater than or equal to 7 to be 10 minus 3. And then we have 2x, so we divide by 2 to find the value of x. And we have to divide the 7 also by 2. So our solution will be s is less than or equal to negative 13 by 2, or s is greater than or equal to 7 by 2. So we can see the range here, less than 13 by 2, greater than 7 by 2. So it can be from negative infinity to negative 13 by 2, or 7 by 2 to positive infinity. So next, we're going to solve the compound inequality with absolute values. Again, in our previous lectures, we solved compound inequalities. So let's go and see one example with absolute. So a compound inequality means we may have the variable in the middle, and we may have either less than, greater than, whatever inequality sign to the left, another inequality sign to the right. This time we have this equation here saying that absolute value of s minus 5 is either greater than 0 or less than or equal to 3. So this inequality is called compound inequality because it consists of two inequalities. And this can be solved separately. So first I can say, okay, I have s minus 5 absolute greater than 0. I take the left side. And also I have s minus 5 less than or equal to 3. Then what we have to do, we apply our condition. Now here we say that the inequality of absolute value s minus 5 greater than 0 is true for all s except 5. Because if it's 5, 0 greater than 0 is false. But if it's 1, yes. If it's 2, yes. Negative 3, negative 1, negative 4 is really, we say it's true for all x except 5. So the inequality s minus 5 less than or equal to 2 is equivalent to the inequality of this. Again, here we say less than. So here we are writing s minus 5 is less than or equal to 3 and also is greater than or equal to negative 3. So this will give us the solution of 8 and 5. S is less than or equal to 8 and greater than or equal to 2. Because we use positive 5 to cancel negative 5. So positive 5 and negative 3 will give me 2. Positive 5 and 3 will give me 8. So that will be the range based on the answer we have. Again, we have from 2 to 8. So from 2 to 8. And we say except 5, so we put the 5. So next is solving equality with two absolute values. So we saw that the absolute value A could be defined as absolute A equal to square root of A square. Remember, square root will cancel square, so that will give us back to this. So now we have a question with two absolute values now, s plus 2 greater than s plus 1. Our goal is to find the value of x. So first we write the equation down, s plus 2 greater than s plus 1. Then we square and square root it, which is the rule. Absolute value means square root and square of the expression. So here we can see that we have square root s plus 2 all square greater than square root s plus 1 square. Not to change here. The only thing is that we are applying this rule. The rule said the absolute value of A is the same as writing A square and the square root of it. And that's what we did here to remove the absolute. So from here we can solve it now. Square root will cancel square root. So we get s plus 2 all square greater than s plus 1 square. We expand the equation to trinomial, or you multiply s plus 2 by itself. You get s squared plus 4s plus 4. And here also you get s squared plus 2s plus 1. Then we need to combine the equation. So we can see that s squared will cancel each other. Because if s squared go to the left side, it will be minus. Or if we use minus s squared, we are going to cancel both. So that's done. So now we have 4 here. So we get 4x greater than 2s minus 3. Why? Because we use negative 4 to cancel the 4 here. So if I cancel the negative 4 here, I will have negative 4 plus 1, which will give me negative 3. So here we get 4s greater than 2s minus 3. The next option, we can cancel 2x. So we have minus 2s minus 2s. So that will give us 2s greater than minus 3, and 2s greater than minus 3. Then we divide by 2 to find the value of x. So our final answer will be negative 3 by 2. And since the answer is s greater than negative 3 by 2, the range will be from -3/2 to positive infinity because it's greater than -3/2. So for us to understand this concept, we also need to understand the properties of absolute value. As we apply the first property of absolute value, we said that absolute value of A is equal to square root of A squared. That's one of the properties. Now, if I have A and B and they are real numbers, we can also say the absolute of AB is the same as separating it. Absolute of A times B is the same as absolute A times absolute B. Same thing with the division. If I have A divided by B absolute, we can separate it saying that absolute of A divided by absolute of B. As far as B is not equal to 0, because we know we cannot divide the value by 0. And the same thing, if I have absolute of A plus B, it's always less than or equal to absolute of A plus absolute of B. Now we say the properties of A and B above indicate that the absolute values of a product or a quotient is the product or the quotient of the absolute values. Absolute value of A and B is the same as absolute value of A times absolute value of B. As absolute value of A divided by B is the same as saying absolute value of A divided by absolute value of B. Now the property number 3 indicates that the absolute value of a sum is either equal to or less than the sum of the two absolute values, A and B, A plus absolute B. So this will be the conclusion of our lectures on absolute values, especially using absolute values in both simple equations and also in inequality equations. So again, wish you the best and thank you for your time.